At this time, I'm going to hand it over to Raj Panaluri. He is going to cover the yellow change and red clearance intervals.
Thank you, Jackie. Good afternoon, everybody, and thank you for being at the Design Update training. I'm Raj Panaluri with the Central Office Traffic Operations Office, and I have my boss, Mr. Fred Heary, here with me. We're going to touch on one of the very interesting and frequently discussed topic of late in traffic operations, and that is the yellow change and red clearance intervals. Probably most of you already know that yellow change and red clearance intervals is referred to in the traffic engineering manual, which is posted on the Florida DOT website. Jackie, just need to scroll to the right. Just click enter. Let's try to just use this one. Oh, thank you. I just thought that we'll have one slide showing the contents of a traffic engineering manual. Like I said, it is available on the Florida DOT website. Essentially, there are 7 chapters, which begins with how the adoption procedure, and then chapter 2 gets into the signs, traffic signals, markings, specialized operational topics such as golf cart crossings, and safe mobility for life, especially elder user issues, and of course the use of technology. The focus today is going to be on section 3.6 of the traffic engineering manual, which is titled as the standardization of yellow change and red clearance intervals for signalized intersections. It is a very brief 3-page section, but there's a lot of important content, and anybody who is in the business of working with traffic signals and signal cycle lengths and so on and so forth, I suggest you definitely read this section a few times. So what was the purpose of this section? It has been around for quite some time, and mainly the intention is to provide a safe transition between any conflicting traffic signal phases. I mean, I think it's common knowledge that when you migrate from a green to the yellow and red phase, you need adequate time so that we can allow the motorists to traverse through the intersection safely. So basically, yellow change interval is defined as the time it takes to warn traffic of an impending change in the right-of-way assignment. And of course, red clearance interval provides additional time following the yellow change interval so that the intersection can be cleared and there's no conflicting traffic sitting in the middle of the intersection. TEM 3.6 draws mainly from 2 main documents, namely the MUTCD, the Manual on Uniform Traffic Control Devices, and the Institute of Transportation Engineers formula, which I'll come to in a few minutes. For additional guidance, it is important that we refer to section 4D.26 of the MUTCD, which provides both the standards, guidelines, and guidelines on the minimum and maximum yellow change intervals, and also the maximum red clearance interval. The reason I highlight this point is because the minimum yellow time according to the MUTCD is 3 seconds, and the maximum should be 6 seconds, shall be 6 seconds. It cannot exceed 6 seconds. And in case of the red clearance interval, it shall not exceed 6 seconds. So this section of TEM, that is 3.6, provides a standard for uniform application of yellow and red clearance intervals. I repeat the word standard, and we say uniform because we expect that all the maintaining agencies would actually comply with section 3.6 of the traffic engineering manual. Just to give some background, Florida Statutes 316.075 provides information about the yellow, green, and red indications, but there's no clear specification or definition of the clearance durations. In other words, the statute is pretty silent on this matter, and therefore section 3.6 makes a lot of gives a lot of importance to defining the red clearance and, of course, yellow change intervals. We refer to, as I said before, the Ite formula, the Institute of Transportation Engineers formula, which has been around for well over 60 years now, and it has been modified over time, and it has become the basis for coming up with the formulae for both yellow change and red clearance interval. If you go through this section in the traffic engineering manual, you will see that there is a reference to what we call the approach speed. When we say approach speed, technically we are talking about the posted speed limit. And the reason we have it as posted speed limit is because that is one measure that is easy to know on roadways, and also it is available readily, and therefore any formula we use or develop are based on the posted speed limit. And for a given posted speed limit, the yellow change interval, as I said before, should not exceed 6 seconds, and it is provided in table 3.6-1, which I'm going to show in a minute for you. The computed values are now the computed values should not be less than 3.4 seconds for a posted speed limit of 1 second. Why is this not moving? Oh, for a posted speed limit of 25 miles per hour. Earlier, that is in the previous version, the minimum was 3 seconds. However, we migrated to a perception reaction time of 1.4 seconds. Let me clarify this point further. Earlier, we used to have a PRT, perception reaction time of 1.0 seconds. In this latest revision, the perception reaction time has been increased to 1.4 seconds. And that is based on the NCHRP, the National Cooperative Highway Research Program report number 731, which says that the 85th percentile perception reaction time tends to be 1.33 seconds, and therefore we have adopted that the PRT time shall henceforward be 1.4 seconds. If we take that increment of 0.4 seconds, the minimum has now turned into 3.4 instead of 3 seconds, and therefore we recommend that 3.4 seconds be the minimum. Any value that is above what is shown in 3.6-1, table 3.6-1, may be used. However, that has to be backed up with engineering practice. The Ite formula has to be applied, and MUTCD 4D.26 shall be followed. And I repeat, under any circumstance, the yellow shall not exceed 6 seconds. Also, the other important provision to note is that the interval durations shall be rounded up to the nearest 0.1 second. In other words, if you have, let us say, a computed value of 3.83 seconds, the usual scientific method is to make it 3.8 seconds, but what we are saying is that it shall be 3.9 seconds. In other words, it shall be updated to the nearest, rounded up to the nearest 0.1 seconds. Of course, as I indicated before, the approach speed being referred to is the posted speed for the approach being analyzed. So here is table 3.6-1 from the traffic engineering manual. And you will notice the approach speed in the left column and the yellow change interval in the right column. All of them are to the first decimal point. And at the bottom, you will notice an important remark that these timings are for grades of 0%. In other words, the traffic engineering manual section does not show the values for grades other than 0%. For that, you may apply engineering judgment and use the Ite formula and come up with the values and follow the standards provided in the section. The formula, of course, is provided in the TEM 3.6, and it comes from Ite. Yellow equals the perception reaction time of 1.4 seconds plus 1.47 V by A times 2 times A plus GG. Pretty straightforward application of the formula, I would say. Coming to the red clearance interval, which is the second part of the section, 3.6.2.2, section 3.6.2.2 provides guidance on the red clearance interval. And it can, it's important to note that red clearance interval can significantly impact the safety at any intersection, because a proper provision would help reduce the probability of occurrence of right-angle crashes. In fact, the formula is also provided in section 3.6, which is shown as R equals W plus L by 1.47 V. And usually one of the questions that comes up about this formula is the calculation of W, that is the width of the intersection. Basically, it is the width of the intersection has to be the length which a vehicle would actually traverse during its traversing path until a conflict occurs from the other side. Several engineers have used a method of drawing circles to calculate that distance and so on and so forth. So depending on the methodology being applied and consistent with engineering judgment, you have to come up with a way to calculate the red clearance interval. And the new revision in the manual is that the minimum red clearance interval is going to be 2 seconds and the maximum shall be 6 seconds. And NCHRP 731 says that this modified Ite formula can allow for a 1 second reduction due to the reaction delay from conflicting movement. But once again, engineering judgment shall be applied for any such reduction when it takes place. The determination to use longer than 2 seconds for red clearance interval should be based on engineer's discretion, and of course that is going to depend on the width of the intersection, the side distance, the complexity of the intersection, the crash history at the location, and of course any other unique conditions that may exist at that location. That is really it for the yellow change and red clearance intervals. It is a pretty straightforward section, but once you start applying, there'll always be questions that would come up. The Florida DOT districts, district traffic operations offices have had a chance to comment on this document, and there was extensive discussion for quite a period of time, not just within traffic ops, but also with other sections. And we'd be very happy to answer any questions you may have. Thank you. There's a question here. Is the table 3.6-1 yellow times, are they the minimums or are they the standards? I would say the answer is yes to both. They are the minimums as well as they are the standards. But mind you, there's a minimum and a maximum value of 3 seconds and 6.0 seconds in the MUTCD, which has to be complied with. Certainly it is a standard, and those are the minimum values. How do you determine grade at an approach if it is a vertical grade? This is a question that has been asked of us previously by a few districts. I think as designers and engineers who are practicing it, this is a question that probably should be answered by designers more than somebody like myself in traffic ops. But I'd like to get clarification from my boss, Fred, as well.
Yeah, I would see it as, if you lower speeds, you've got to use engineering judgment. Lower speeds where the portion of where you're braking, is it 100 or 200 feet or whatever. I don't think it'll be a fixed number for, higher speed roadways. It's all because when you're braking and the gravitational effects are combined with that to help you get your distance. So just as engineers, you'd have to take that into consideration.
Right. I mean, we always emphasize that one has to consider the local geometry and then have a good understanding of field conditions when we come up with grade calculations. I mean, you have complex curves, you have simple curves, and so on and so forth. There are no other questions. We appreciate your time. Thank you.